So, welcome back. Those of you that have been following my videos, Math 150, that's beginning algebra. Here at Santa Rosa Junior College, we call it 150. And we're now into chapter 5. And a couple of the topics in chapter 5 is going to be exponents. And then we're going to learn about polynomials, what a polynomial is, and how to add, subtract, multiply, and even divide polynomials. But first thing, we're going to look at exponents, which another word for this maybe it would be powers, P-O, powers. Exponents are powers. And a number of you just know how to speak this, meaning how do you speak that? You might say 2 raised to the power of 3. 2 raised to the power of 3, or sometimes we might just say 2 cubed. 2 cubed. What it means is 2 times 2 times 2. It does not mean 2 plus 2 plus 2. It's not 6, but that's an easy mistake to be made. The answer to this is 8, not 6. Likewise for this, you'd have 2 times, you have 4 of these 2's, so that's 16. Now these two right here, they you'd think they're the same, but they're not. The power of 4 is touching the parentheses. The power of 4 means write down 4 of those parentheses like this. And then what's inside the parentheses is a negative 2. So it's negative 2 with parentheses, and there's 4 of them, and thereby getting a positive result. 4 negatives make a positive. Negative, negative, negative. 4 negatives make a positive. So positive 16. Unlike this one, the power of 4 is only on the 2. Is only on the 2. That negative remains, just one negative, and there's 1, 2, 3, 4. And because the 4 is not touching the negative, it was intended to, you'd have to have it on the parentheses right there. So there's one negative left, of course, and that's negative 16. Okay, this one here, again, the 3 is not on the negative, so leave it here with just a negative, but then there's 1, 2, 3, 3 2's, negative 8. And here, to write this out correctly, you would write down 3 parentheses, 3 negatives, still a negative, and that's 8. X to the 4th, just another way of writing it, because you don't know what the value of x is, but rewriting x to the 4th, you just write down the x 4 times. This one, 2 is touching the parentheses. I highly recommend that you write the 2 parentheses down. 2 is touching the parentheses, so it's 2 parentheses, negative a half with an x and a y, negative a half and an x and a y. Now what you can do is rearrange all the terms, well, not terms, but all the values that are being multiplied, and understand that the powers right here. See, well, think about it. 1, 2, 3, 4. 4. 1, 2, 3. 3. 1, 2. So that's x to the 2nd power. Y has a power 1, a power 1. Y to the 2nd. And then negative a half times negative a half is positive 1/4. Which leads me to some rules for exponents. We have rules or laws for exponents. This says if the base is the same, you add the exponents. See the previous problem, well, just like this one. If the bases are the same and you're multiplying. All right, I'll go back to the last problem. Yeah, base is the same right here. Base are the same, you add the exponents, 1, 2, 3, 4. Bases are the same, you add the exponents, and that's 2. So bases are the same, add exponents, 4. Bases are the same, you add the exponents. 6 17th, y to the 17th. Uh, 6 times 4 is 24. Bases are the same, 2 and 5, 2 plus 5. 24 to the 7th power, excuse me, x to the 7th power. Multiply the numbers together, meaning negative 4, 4 times negative 3, so that's negative 12. X, there's a power 1 here, x to the 1 plus 2, x to the 3rd. So when the bases are the same, you add exponents. Unlike a problem that looks like this is where you've got a parentheses with a power on the outside. You will multiply the exponents here together. 7 times 3 is 21, x to the 21st. See, if I wrote this down twice, you don't have to do it this way, but if I wrote y to the 5th times y to the 5th, and you say, hey, bases are the same, add the exponents, you get 10, but you also get 10 if you multiply these together. So that's kind of like the shortcut, y to the 10th. Okay, multiply exponents. Don't forget there has to be an exponent on everything, including the 3 right here. So that's 3 to the 1 times 2. See, these two things are going to get multiplied. So 1 times 2, x to the 2 times 2, y to the 5 times 2. And of course, simplifying gives you 3 to the 2nd, x to the 4th, and y to the 10th. And 3 squared is more commonly known as 9, x to the 4th, y to the 10th, is probably the best looking answer, and that's what you'd box. Okay, power 4 means write this down 4 times if you wanted to, but there's a shortcut to simplify. The power 4 is going to get multiplied to, of course, those powers right there, but you have to include the powers on the negative and the 2 and the 3. Think of this. There's 4 negatives. There's 4 2's. There's 4 x cubes. 4 negatives make a positive. 2 to the 4th power and x to the 3 times 4, which is 12. Over here, 3 to the 1 times 4, 1 times 4, and then y to the 2 times 4. Simplifying this, that's 16, x to the 12th all over 3 to the 4th. Okay, 3 to the 4th is really 81, so you could write 81 if you needed to. Just check the back of the book and see what they have. So 3 to the 4th down below, or 81 down below. Okay, another rule, subtract the exponents. Well, think about this. All right, 2 to the 4th is 16. That's 16 all over 2. Isn't 16 over 2 8? Well, it's the same thing as if I subtracted these exponents. 4 subtract 1 is 3. 2 to the 3rd is 8. So what you'll do is y to the 5 subtract 3. So it's y to the 2nd. There's a power of 1 right there, so subtract the exponents. That's x to the 3 subtract 1 times w to the, okay, now it gets a little weird here. You get 4 subtract 5 and you get a -1. 4 subtract 5. Here you get x to the second and w to the -1. You're going to find out this chapter, towards the end, you'll find out that you don't want negative exponents at the end. So eventually that will be a problem right there, w to the -1. I'm going to leave it for right now, but eventually you'll want to make that a positive 1 somehow. Okay, here, okay, the rule says if the bases are the same, you're multiplying, you're going to add the exponents. So 2, 7 is 9, plus 1 more is 10. That 4 touches the parentheses. That 4 does not affect that 4. You're going to have this 4 times a to the 2 times 4. Looks like you get 12a to the 10th over 4a to the 8th. Yes, you can reduce. 12 over 4 is 3. Subtract these exponents, and you'll get 3a to the second when you're done. 10 subtract 8 is 2. Okay, here, take care of the powers. That's x to the 4th, y to the 6th, x to the 4th, y to the 6th. Subtract exponents. Okay, 3 parentheses, or 3 negatives, 3 2s, 3 r cubes. So my thought could be 3 negatives is a negative. Let's multiply exponents, because that's one of the rules we had, is that you have a parentheses on the outside, you get to multiply exponents. So 2 to the 3rd, r to the 9th, r to the 9th, multiply exponents. 3 to the 3rd, r to the 12th, and r to the 3rd. And now you simplify maybe the numerator pieces. That's -8, r to the 18th, because you're adding the exponents here. This is 3 cubed is 27, r to the 15th. And then finally, you're going to subtract exponents because the bases are the same. So you subtract exponents right here. The base is the same as a quotient. You go numerator, subtract denominator. Numerator, subtract denominator. Numerator 18, subtract 15. -8 r to the 3rd, but you still have a 27 down below. A couple other facts. 2 to the 0 is 1. Anything to the 0 is 1. And some of you are saying, I don't know why. Well, I'm going to prove that at least to the calculator, if I raise 2 to the 0 power, you get 1. So if I wanted to explain why that might be true, if you had 5 to the 4th over 5 to the 4th, aren't those identically the same? So if that's true, it's 1. But if I use the rule that you subtract exponents, so 5 to the 0 is 1. Okay. So you are finished. I am finished. And that's all I have for you today. That's 5.1, which is the beginning part of exponents, rules for exponents. And so until the next time, 5.2, see you later.